Have you ever stopped and wondered how a brand new car gets built so fast? Or how a busy hospital manages to treat hundreds of different patients, all with unique problems every single day? Well, the secret isn't just about working hard. It's about smart design. Today, we're going to pull back the curtain on the hidden architecture behind literally every product and service we use. We're talking about production process design and layouts. Let's jump in.
Here's our game plan. We're going to start with the basics, laying the blueprint of what process design even is. Then we'll get into the fun part, exploring how you actually arrange a physical workspace by picking the right layout. After that, we'll look at how managers measure and standardize the work itself. And of course, we'll wrap it all up with the key takeaways you'll definitely want to remember. Okay, so first things first. Before you can build anything, doesn't matter if it's a factory, a restaurant, or even a software app, you need a plan. A blueprint. And in the world of operations, that blueprint is called process design. Think of it like this. Process design is the master plan. It decides the what, the who, and the how of getting something done. It maps out the exact sequence of steps, what tools and people you need at each of those steps, and all the rules to make sure everything runs like a well-oiled machine. If you get this part right, you're setting yourself up for success. But if you get it wrong, well, you're basically building inefficiency right into the system from day one. And this isn't just some random sketch on a napkin either. It's a really methodical three-step journey. First, you've got to define your goals. What are you actually trying to do, and how much of it do you need to make? Step 2, you develop the actual process. Brainstorming ideas, picking the best design, maybe even building a small-scale model or a prototype. And finally, you test it out with trial runs to see how it performs in the real world before you go all in. Okay, so once you've got that blueprint, it's time to actually build the house. Choosing a layout is all about the physical arrangement of your resources, your people, your machines, your materials. This is where the design literally comes to life on the factory floor or in the office. Let's kick this off with a classic challenge. I want you to imagine you're Henry Ford for a second. Your mission is to build millions of Model T cars. They all have to be identical, and you need to crank them out as quickly and as cheaply as humanly possible. So how do you set up your factory to pull that off? Well, the answer is the product layout, which you probably know better as the good old assembly line. Everything is arranged in a straight line, following the exact sequence of steps you need to make the thing. It is designed for one purpose and one purpose only, to create a super smooth, non-stop rapid flow. A great example is an automatic car wash. Your car just moves through this fixed sequence of stations. Soap, rinse, dry, boom, done. Now, the thing about the product layout is that it's all about trade-offs. The upside is just incredible efficiency. You can make things lightning fast and super cheap with almost no waste. But the downside? Man, it costs a fortune to set up. The jobs can be mind-numbingly repetitive for the workers, and the system is completely inflexible. If you decide you want to change the product, you might have to redo the entire line. But what if you're facing the complete opposite problem? You're not making a million identical things. Instead, you're running a custom workshop where every job that comes through the door is different from the last. How do you handle that? For that, you need something totally different, a process layout. Here, instead of a line, you group similar equipment and skills together. So all the drilling machines are in one area, all the welding stations are in another. A hospital is a perfect real-world example of this. You've got a radiology department, a surgery department, a pharmacy, and patients, they move between these different functional areas based on their unique medical needs. So the whole design challenge shifts here. It's not about creating a linear flow anymore. Now the main goal is to arrange these departments to cut down on the travel time and cost of moving people or materials between them. The puzzle becomes, which departments interact the most, and how do we get them as close to each other as possible? Okay, so we've got pure efficiency on one side and pure flexibility on the other. But what if you need both? What if you want the speed of an assembly line, but also the ability to handle some product variety? This is kind of the holy grail for a lot of companies. And this is where the solution gets really clever, the cellular layout. It's a brilliant hybrid. The secret sauce here is something called group technology. You basically analyze all the different parts you make and group them into families that need similar manufacturing steps. Then, you create a dedicated little mini factory, a cell, for each family. It's like having a bunch of small, focused assembly lines inside a bigger, more flexible factory. And the benefits are huge. You can get things through the system way faster, you often need less floor space, and you still have a ton of flexibility. The main challenge, though, is that you might need to buy duplicate equipment for different cells, and balancing the workload between all of them can get pretty complex. Now, this slide right here, this is your ultimate cheat sheet. It lines up all three layouts side by side and compares them on the most important factors: volume, variety, worker skill, and the type of equipment you need. It's simple, right? High volume, low variety, you go with a product layout. Low volume, but tons of variety, process layout is your friend. And if you're somewhere in that sweet spot in the middle, cellular is probably your best bet. So, you've designed the physical space. The layout is set. The next big challenge is to define the actual work that happens inside that space. This means figuring out how long a task should take and making sure that everyone does it the exact same way every single time. The goal of all this measurement is to figure out something called the standard time. Now, this isn't about the fastest time anyone has ever done the task. It's about setting a realistic, sustainable benchmark for how long a task should take for a trained worker who's working at a normal, steady pace. This number becomes the baseline for everything, from scheduling work to figuring out payroll. So, how do you find this magic number? Well, the classic way is with a stopwatch time study. You literally observe an employee and time them doing the task. That gives you your observed time. But hey, what if they were working super fast that day, or maybe a bit slow? You adjust for that with a performance rating, which gives you the normal time. And finally, you add an allowance for things you can't avoid, like breaks or small delays, to get that final, official standard time. The other side of this coin is standardization. This is all about deliberately removing variety to create consistency and predictability. It means using the same parts, the same tools, and the exact same work methods every single time. The whole goal is to make the process repeatable and reliable. And here we see that classic trade-off pop up again. By standardizing, you get massive benefits. It's way cheaper to buy parts in bulk, it's simpler to manage your inventory and train new employees, and it gives you a stable process that you can actually improve over time. The one big drawback? You offer less choice to your customers. All right, we have covered a ton of ground, from high-level blueprints all the way down to stopwatches on the factory floor. So let's pull it all together and lock in the key things you should take away from all this. So, let's recap. First, process design is your foundational blueprint for how all work gets done, period. Second, your choice of layout always comes down to that trade-off between volume and variety. Remember, product layout is for high volume and pure efficiency. Process layout is for high variety and total flexibility. And the cellular layout is that clever hybrid that tries to get you a little of both. And finally, don't forget that measuring and standardizing work is what creates a stable, predictable system, which is the absolute essential foundation for making things better over time. So to wrap this up, I want to leave you with a little challenge. The next time you're out grabbing a coffee or a burger, just take a second and look around. What kind of layout do you see? Is it a product layout designed for pure speed, a process layout with different stations for different tasks, or maybe even a little cellular hybrid? See if you can spot the design choices they made, and more importantly, ask yourself why they made them. Thanks for tuning in.